Hello, welcome to today's Stockholm webinar. Just mentioning the housekeeping items very quickly. The webinar slides are available to download in the handout box on the control panel as a PDF. And also there will be time for question and answers, so please log your questions in the question box on the control panel. I will hand it over to Søren to start the presentation. Thanks, everyone.
Thank you very much, Sharon. Today I'll talk about stormwater detention pond and our work with adding benefits to the stormwater detention ponds. But just briefly about myself and the department I'm sitting in. I'm a part of WSP Denmark, and I'm in the Department of Climate and Sustainability and Urban Development. In our department, we are working with urban development and planning projects. That's mostly new development, but also changing existing cities. Then we're working a lot with stormwater management, and especially climate adaptation, and you can find quite a few webinars on this topic. We have a group working with hydraulic modeling, besides our landscape architects working with design. And then we started 2 years ago working with life cycle assessment and CO2 calculation on our projects. But today's topic is stormwater management, and I've been working in this field for now like 30 years or something, 27 years in WSP. And for me, it has been an interesting topic all the time, and it has been developing a lot, and it is still developing. We just got a project for the Danish EPA, which is about making new guidelines for stormwater management, stormwater handling and purification, partly in stormwater detention ponds. And I hope we'll come back on that next year in a Snag and Learn webinar. Today's program, I'll just go briefly through standard detention stormwater pond designs, and then I'll go through a guideline we made for how to make ponds with added benefits, and talk about levels of access to water, risk handling and hygiene. I'll talk about how we work actively with developing nature and biodiversity in stormwater ponds, and briefly mention maintenance, and then I've got 3 projects as examples with a lot of photos in the end. Well, about the standard designs of stormwater detention ponds, we made, that's WSP, at that time we were called Orbicon, that was before we became a part of WSP. We made together with the Danish EPA and University of Aalborg guidelines, which are considered best available technology in Denmark for how to design stormwater detention ponds. And they're designed with 2 goals in mind. One is purification of the water, and the other is detention of the water. Purification, that's due to not polluting our recipients. And to make sure we have a decent purification of the water, we design with a 250 cubic meters permanent wet volume per hectare paved catchment. And what happens here is that we can contain about 25 millimeters of precipitation in the pond. And then when it starts raining, the clean water will be removed and discharged, and new polluted water from the urban surfaces will be collected in the pond and stand there for days until next time it rains. So that's the purification part of it. The detention volume, we have that because the rivers and streams in Denmark are quite small, and therefore they're sensitive to hydraulic loads. So normally we would only be allowed to let out maybe 1 liter per second per paved hectare catchment, and that takes a detention volume from 600 to 900 cubic meters, depending how much we can let out and how much it's raining in that part of our country. I've linked in the bottom here, I've linked to a fact sheet about design and a background report. They're both in Danish, but I've got good experience with converting them to Word and then using our auto-translate. They're richly illustrated, so I can just recommend to download them. Apart from this, I'll not talk more about standards design of detention pond, but go more into how we're working with recreational values and biodiversity and nature in the ponds. And we came into this because I've been working with ponds for like 30 years, and all the time I've added they can be used for more than water purification. And in Denmark, we had an accident back in 1986 where a child drowned in a stormwater detention pond. And at that time, the EPA wrote to the municipalities they had to consider whether they should put fence around their ponds or not. But we have lots of natural lakes, we have harbors, coastline all over, but still half of the municipalities decided to fence their ponds. And for that reason, there hasn't been a lot of focus on recreational use, but we wanted to change that. We did that by making guidelines. We did it together with the institute called Teknologisk Institut, and we did it for the Danish EPA, partly funded from private money as well, and utility money. These guidelines, you can download them as well, and they're really richly illustrated with principal drawings and a lot of photos. It contains a planning guide, it contains a chapter about safety, about hygiene, and then about nature and how we design with nature, and then a lot of design examples. And briefly about the planning. The planning is all about how we plan for access to water. And you could say we have 3 levels of access. Water meant for looking at the water, where safety is the distance from the path to the water is the safety measure. And in this situation, you're getting close to the water, and then in the last situation, you're planning with contact to the water, where kids are and people are playing along the water or even on the water. Here are 3 examples. The first picture, we have got distance and plants to ensure that people don't fall in the water. Second example, you have access to the water. The path goes just by, it's close to a school. And the last example, people are actually playing on the water, in this case, on like a simple bridge. Risk handling is all about to take measures that fits the access you've got to water. This is from another project. I love the project. It's beautifully designed, but when it comes to safety, I consider this quite dangerous, because here's a bridge. Everybody has access to the bridge, and the water around the bridge is about 1 meter deep. So for adults, it's not a problem, but if kids fall in and they're alone, they're into problems. So you should take into consideration who are the users and how can you ensure that they don't fall in deep water. And of course, you can do it in different ways. You can use fences or you can use distance. But the goal is that people should have experiences, but they shouldn't drown or risk to be close to drowning. So what we're using is shallow water, firm bottom and flat banks. So when you fall in the water, and we are planning for not if, but when you are able to get up, you could use fences. Another thing which is important, that's surveillance and good overview conditions. So where there's access to the water, you have to make sure that the kids cannot just hide behind the stones and bushes and so on. And then, of course, you can use large boards and so on, but that's a secondary measure. Normally, we plan more passively with the security. And the last thing is in the risk handling is handling the user sensitivity and take into the considerations who are the users. So when you're planning for playing with the water, of course, you should plan with shallow water. And when we have kids playing on the water, close to the water, we have a maximum water depth of 40 centimeters. And that makes it possible for a kid with an age of 2, when they fall in the water, to keep their head over the water. But still, there is a risk, but we haven't had any accidents in this type of ponds yet. Another thing is hygiene, because this is not clean water. It's stormwater that has washed surfaces, roofs, and roads, and so on. And hygiene is relevant when you plan for contact to the water. So if it's just a lake meant for looking at it and walking around it, hygiene is not that relevant. But as soon as you start planning for contact with the water, in this case, as a water playground supplied with water from a detention pond, you have to make sure that the water is relatively clean. And you can do that by taking water from the middle of the pond, and you have to, of course, make sure that you don't have any faulty connection of wastewater to a stormwater sewer system. Large number of birds has also shown to give problems with hygienic things. The picture on the right here, I would not make a project like this because the facility that's installed here looks like a tap and it invites kids to drink from it. So we would always let the water out at the surface level so you cannot drink from it, or at least you should really be decided to drink from it. Development of nature and stormwater ponds is very interesting because no matter what you do, they turn into nature. And from a planning and regulatory perspective, if you've got open water for more than 3 years, it's considered nature in a Danish context. And you have a very fast succession of nature and ponds. This is a pond we established back in 2013 in June. The same pond in August, same year. And then 3 years later, in August 2016, where it's a fully developed pond. And already the first year we had amphibians and frogs and everything in the pond. And that's a good thing. When it comes to maintaining, we have a discussion about regulation. And of course, you have to make sure that you can be allowed to maintain the ponds, because over some years, they'll fill up with sediment, they'll fill up with plants. And after maybe 30 years, you'll have to dig out sediment from the pond. And then you have to, in your planning, take into consideration that you should have an allowance to do that. So if you're looking into the biodiversity in the system, our experience is that just after the pond is established, you have a low content of nature in the pond. But just after the first year, maybe 2 or 3 years, the biodiversity raises here, and we have whatever aquatic life we would want there. And then after some years, when the ponds start to fill up with sediment and start to fill up with plants and so on, the biodiversity will decline. So it's in everybody's interest that we do this maintenance on the ponds. And it is necessary because as the ponds are designed for purification of the water, they work as sediment traps. So we have sediment building up in the pond, and if we use our design criteria, our experience is that we'll have about 1 centimeter of sediment build up per year. And that means that every like 30 or 50 years, you have to dig up the sediment, and then the pond has to start over again. And you have to take that into consideration in the planning, so it's accepted by the environmental authorities that even though you have frogs and amphibians in the pond, you are allowed to dig it out. There's been a lot of discussion about that, but when you take it in the early planning, it's easy. Here's another example of bad maintenance. This bench was established because there was a great lake view, but after 20 years, everything was completely grown, so you can't see the lake anymore. So plan for maintenance. And then for some project examples, I'll talk briefly about Haraldsminde, a project we established 2 years ago, Værebroparken, an old detention pond which we made bigger and dug out the sediment some 5 years ago, and then Søren, another project we made some 6 years ago, a new project. The Haraldsminde project is a part of the Haraldsminde cloudburst capacity plan, where in the western part of Copenhagen, we've got this stream running from north to south, and then we have a stream coming from west here, and on the top of this, we've got this Haraldsminde area. And the entire idea about the project is to make detention capacity for normal everyday rain and for cloudburst. So we have established this pond as the first project of the Haraldsminde capacity plan, and the entire budget for this is about 300 million euros for the entire capacity plan. And the pond we made out here was at a price of about €1 million. Here's a sketch of the pond and what we planned, and on the left you can see where you have the water table in case of no rain, in case of heavy rain up to a 5 years event, and then in the case where we had really heavy rain or several heavy rain events after each other. And you can see we have planned some bridges here, and that's because we have inlets to the pond here, and below these bridges we have built a dam. So these enclosed area of the pond works as primary sedimentation ponds or traps, and by doing that we can clean up these areas maybe every 10 to 20 years, and then we can leave the rest of the pond and only clean it up maybe every 50 years. This is what it ended up like. It's just after it was established. You can see two of the bridges here. And again, a visualization of what we planned for. And this is the photo just after it was established. You can see a bridge in the foreground here and one in the back. Those were the bridges we established. And I was out there just after several days of heavy rain, and the bridge were completely flooded as planned. And I drove them with my bike, and there were a group of old ladies my age, and they were like, "Can you drive the bridge even when it's flooded?" And they went out there. I got this picture. It's great to see people using the area that way. And here I would say we have planned with the passive safety. So if they fall in the water, it's quite shallow. Another example is here in the Værebro Park. There was a pond, 40 years old pond. This is a social housing area. We've got a school and a swimming facility here, and then we've got the pond down here. And the idea about the project was that we had to remove the existing sediment, and then we had to dig the pond bigger than it is today. So we had to make another 1,500 cubic meters of detention capacity. And the utility company wanted to reuse the soil in the area, and they got into a discussion with the people owning the area. That was partly the social housing company, partly the municipality. And they accepted it if they put money into a design of the pond, so they could improve the use of the area. We had a lot of planning about how to make the paths with a lot of crossings. So we had activities. We put the crossings in the area here, and we built this wall through the pond because we had the inlet and the outlet in the same facility here, and we wanted the water to go all the way through the pond to ensure we had some cleaning. That's why we built the wall in the center of the pond here. And then we made shallow water and some railings, so when you fall in the water, you can actually get up again. And here it's a colleague of mine walking on this wall, but it's just next to a school. So we have a lot of kids playing there as well. And they have learned they shouldn't bring their cell phones there because they fall in the water over and over again. But the school loves the place. And then we used the water locally, and the utility company then paid for some simple playgrounds and a play-friendly terrain. Here we've got the finished project, and then we had the entire area flooded after a very long and heavy rain. Another project, Søren, that's just next to Lake Viborg in the background here. It was established because they wanted to purify the water before it ended in the lake, and because they wanted to add recreative values to the area. So it's the same area before and after we made this project. We designed it together with some architects called Møller and Grønborg, and we were the engineers and construction people in this. We have the lake or the pond here. There's no detention because it's just purification. And then we have this area here with a stream going through it, or it's just shallow water. And we made a lot of crossings here, and they're an important part of the design. Here you can see an aerial view. And then there's, of course, access to the water all around the pond. Crossings, again, on the dam close to the inlet here. And then we have made crossings over this small stream we have made, and we made 13 different crossings. And it was really cheap, and I would say it has a huge play value. I was there with my wife, and we had to establish a parking lot. And there were some 60 cars there, just people visiting this rainwater detention pond. So it has really become an activity in the area. So lots of crossings, all of them cheap and simple. And people get wet. If I should finish with some key takeaways from our work here, I would say that water in the city is important, and we need it for detention purposes, of course. But if you plan with it, it can provide space for play and nature, and we need that in the cities and the suburbs. And stormwater detention ponds are suitable for this if we plan for it in advance and if we design it for it. We can have a huge nature content, and we have made this guideline to say how we can do it and how we can maintain the ponds so we can have nature and safe access to the water. But it should be taken into the project from the very start. And I would just say, go there, try it, and seek inspiration in our guideline here. And feel welcome to contact us if you want to learn more. Thank you.
Thank you, Søren, for a fantastic presentation. Oh, the slide is missing. Okay. So the presentation slides are available to download in the handout box in the control panel. You can download and you can access the links in Søren's presentation. And also please continue to log your questions in the question box for this Q&A session now. I will start with the first question. How long after construction of the detention ponds is data gathered on water quality and habitat? And also, what are the metrics of success?
I would say, in general, when we make detention ponds, there's no monitoring on nature or water quality. And that's the idea about having this standard design guide for how to design and dimension detention ponds. But we have, of course, as a background material for this, made monitoring on detention ponds. And our experience is that when it comes to suspended solids, we can retain about 80% of the suspended solid in the pond on annual basis from the rain. We have also measured nutrients and heavy metals in the ponds, and what we see is it's mainly heavy metals and nutrients which are adsorbed to particles that's retained in the pond. During the summer period, we can have after some years when there's sediment in the pond, we can have a release of phosphorus, one of the nutrients from the sediment, but that's very similar to normal shallow eutrophic lakes.
Thank you. Next question is how to prevent eutrophication when you collect agricultural water in stormwater retention ponds.
Yeah, that's a good one. I would say stormwater detention ponds, we try to keep agricultural water out of them because stormwater is quite, there are quite low concentrations of nutrients, nitrogen and phosphorus in stormwater, and therefore you can have quite a good water quality in the ponds, quite clear water. But as soon as you get agricultural water into the ponds, you'll get a lot of nutrients in the ponds and they'll fill up with algae. So I would plan for keeping agricultural water out of the ponds and make separate systems for them. We make ponds specifically for agricultural water and design them for denitrification of the water. So we use them for purification of the water for nitrogen. But that's another kind of ponds we use for that purpose.
Thank you. We have here two questions related to funding. The first one is how was funding obtained for this project, and also are funding shared between Recreation Department and Engineering?
Yeah, the regulation in Denmark is so that the utility company, they're only allowed to pay for that part of the project that's about handling water. And in the case with the Værebro project, where we had to enlarge the detention volume, the utility company, they saved about, what's that in euro? About 150,000 euros by keeping the soil we were digging out, by keeping that in the area. And they were allowed to spend some money on building a new landscape and establish some simple facilities. And the wall, which you can see in the photo here, that was the part of the purification. So that was paid for by the utility company. The Sønnes project, this very big pond I showed in the end, it was partly financed by private fundings. But in general, if you want to make anything recreational, it has to be paid by tax money, where the more technical stuff is paid by sewer money. But again, when you make the design, it doesn't cost more for the utility company to make a pond with a good design and a nature-friendly design than just a normal pond. And if you save the fence, you save money for the utility company.
Thank you. Lots of questions and comments are coming. I will read the next one. It's about the removal of sediments from the pond. What are the best techniques to do that?
Yeah, I think we'll make a presentation about that next year, but we had different ways to do it. The easiest way is to empty the pond for water and then dig it up. These ponds are artificially made, and they would have normally, with our soil condition, a clay bottom, so we can dig it out. We can also grab it up from a water-filled pond or pump it up. If you pump it up, you'll mix a lot of water into it. The sediment would naturally end up with 80% of water, and it cannot be pumped up, but it can be dug up. When you pump it up, you'll end up with maybe 97% of water, and you have a lot more sediment. But we have like a key figure saying that the sediment removal would cost about, what's that in euro, 350 euros per hectare paved area catchment per year. But then you do it every 30 years, so it's quite a lot of money when you do it.
Thank you. The next question, sorry, from idea to generation to completion, how long did it take to complete these projects?
The one here on the picture, we spent 1.5 years. The Søren project, it was a little more than 2 years, and the first one where we had these dams under the bridges, it was again 1.5 years, I think.
Thank you.
We did some public participation, especially with the one on the photo here. So we had the school involved and the social housing area involved in the design, and it took some time, but they had a lot of good inputs. And we wouldn't have been allowed to do something as wild as this if they hadn't wished it.
Thank you. Who maintains the ponds, the crossing, and what is the lifespan of wood crossing?
The maintenance is split between the utility company and the municipality. So the utility company, again, they pay for what has got to do with water handling. So they remove sediments and they cut the grass, mow the grass in that part of the pond which is flooded. So it's all the areas nearby the ponds which are maintained by the utility company. The rest is paid by the municipality. This wall, it's made from SOB, so it would last for maybe 80 years. But when we use normal wood, we use oak or something, and that would last for maybe 30 years under Danish conditions.
Thank you. During times of hot weather, is it common for people to paddle or bath in stormwater ponds in Denmark, or are there any signs to prevent this?
We have, I would say, normally stormwater ponds are not very big and not inviting for swimming or for paddling. But we have some big stormwater detention ponds with signs saying that we don't recommend swimming. But again, I would say if the pond is as big as a natural lake, that's several hectares, and you don't swim just after rain, I would consider it okay. But normally, if we open an area for swimming, it wouldn't be a detention pond, and we would measure the water quality. That we do that in swimming lakes. We don't do that in detention ponds.
Thank you for clarifying. Thanks, Søren. Fantastic presentation. Thank you for all your questions. So just mentioning again, this guideline is available only in Danish. You can download it from the link here, and also it will be sent to all of you who registered. So thank you very much for this. You can use translation tools to use it, but as Søren mentioned, it's a lot of illustrations to clarify the meaning there. So thanks again. Really positive feedback, Søren. Beautiful and inspiring projects. So thank you very much for joining us today. We had amazing interest in this project. So thank you all for joining and for your time. We will wrap up the session now. Thanks all.
Thank you. Bye.